In this section we're looking at asymptotes. An asymptote is an imaginary line that generally our graph tends to go towards. So here we have this vertical imaginary line which is called a vertical asymptote, and we have a horizontal imaginary line which is called a horizontal asymptote. As you can see, our equation f of x is equal to 2 over x minus 1. Our graph is approaching infinity as our x value is approaching 1. Now as our x value approach 1 from the left hand side, our y value is approaching negative infinity. So here we're saying that from the left hand side of 1, the y value or the limit approaches negative infinity. Now from the right hand side of 1, as x approaches 1 from the right of this function, the limit approaches infinity. Now every time that the limit approaches infinity, as we approach an x value, that x value is known as a vertical asymptote, and our vertical asymptotes occur where x is equal to that number. So here our vertical asymptotes for this equation would be x is equal to 1. Now for our horizontal asymptotes, we're looking at the y value. So we're looking for what y would be equal to. This time we're looking at y would be equal to as x approaches infinity. So as we follow this and x is approaching infinity, we notice that the x, we're getting closer and closer to y is equal to 0. The y value is getting smaller, where it never really touches our horizontal in this case. And if we look at it from the other side, as we approach negative infinity on the x-axis, we're getting closer and closer again to the x-axis, but never really touch the x-axis. Now, do not forget, where the x-axis is, y is equal to 0. So our horizontal asymptote in this problem is where y is equal to 0. Now let's look at finding vertical asymptotes. Our first step in finding a vertical asymptote is to simplify a rational function such as this or this, if possible. Now, after we simplify, we're going to set the denominator equal to 0 and solve it. By setting the denominator equal to 0 and solve it, this will give us our vertical asymptotes. So if we take this first example here, if we factor the denominator, we have x times x plus 3. Now, x minus 3 over x times x plus 3 cannot be simplified. Therefore, we can go to step 2, which is setting the denominator equal to 0 and solve it. So we have x is equal to 0, or x plus 3 is equal to 0. Or x is equal to, if we subtract 3 from both sides, we'll see that x is equal to 0 or x is equal to negative 3. So this problem will have two vertical asymptotes. One at x is equal to 0 and one at x is equal to negative 3. Now in this example here, we have f of x is equal to x over x squared plus 6x. Now if we try again to simplify this rational function by first factoring it, so we can factor x from the denominator, leaving us with x plus 6, we see that we can simplify this rational function. We can cancel our x's, which leaves us with 1 over x plus 6. So our denominator in this problem is now only x plus 6. Setting our denominator equal to 0 and solving it, we have x is equal to negative 6. So for this rational function, we have one vertical asymptote where x is equal to negative 6. Now let's look at finding the horizontal asymptotes of a rational function. If you have a rational function in its simplified form, where we have an expression or a polynomial about being divided by another polynomial. Here our numerator is an, which is our leading coefficient, times x to the n, which is our leading degree, and this is all over bm. This is our leading coefficient on our denominator, and xm, which is our leading degree on our denominator. Now, three simple conditions here will tell us what our horizontal asymptotes are. If m, which is our degree here on our denominator, is greater than the degree in our numerator, so if our degree on our denominator is greater than the degree in our numerator, then our horizontal asymptote is the line y is equal to 0. Now, if m and n are the same, for example, they're both 2 or both 3 or both 4, then the horizontal asymptote is the quotient of dividing an over bm. So y would then be an over bm. However, if m, the degree of our denominator, is less than the degree of our numerator, then there is no horizontal asymptote. We will now look at a few examples demonstrating this process. So here we have three examples of finding a horizontal asymptote. In our first example, we have f of x as being equal to 4x minus 3 all over 2x plus 1. This is unfactorable both the numerator and denominator, so this cannot be simplified. Now, since this is not going to be simplified, we can examine first our degree. We notice that the degree on the numerator is 1, and the degree on the denominator is also 1. That means the degree of both of these are the same. Now, if the degrees of our numerator and our denominator are the same, then our horizontal asymptote is y is equal to a over b, or in this case 4 over 2. So y is equal to 2. So our horizontal asymptote would be where y is equal to 2. Now, in this example here, we have x to the third minus 2x squared plus 3x plus 1. And this is all over x squared minus 3x plus 2. We can see that the degree on the numerator is 3, and the degree on our denominator is 2. Since the degree on our numerator is greater than the degree on our denominator, then we know there is no horizontal asymptote. Now, this final example, we have 3x over 4x squared minus 1. So, the degree on our numerator here is 1. The degree on our denominator is 2. Here the degree on our numerator is less than the degree in our denominator. Because the degree on our numerator is less than the denominator, then we know our horizontal asymptote is always y is equal to 0. When the numerator degree is less than the denominator degree.